Okay. All right, guys, so we are talking solving systems still, except this time we're talking solving systems of inequalities. And before, when we solved systems of equations, we could, use substitution, elimination, all that stuff. But for solving systems of inequality, we actually have to do it by graphing. All right, so there's kind of like no choice there. All right, so to solve a system of inequality, basically, you just graph inequalities in the same coordinate plane. So that's step one. And then the solution of the system is the intersection of the shaded regions, okay? So the region shaded for all inequalities. Okay, so basically it's gonna do something like this where you're gonna have a graph and let's say you shade down for this one, and then if you have like another graph and then you shade for that one, the intersection of those two regions, this green part, will be your solution. All right, so where the inequalities intersect, that will be your solution region. All right, so your answers will be a region. All right, so let me go ahead and show you guys some examples. The directions say, solve each system of inequalities by graphing. Okay, so I'm gonna jump to number 3. All right, I'm gonna jump to number 3. So the first thing I need to do is I need to solve by graphing. So I need to put this into slope-intercept form, okay? So help me out with that. Let me call on Timothy. All right, Timothy, can you help me put this in slope-intercept form? The first one. So like solve for y, basically.
So it would be, which one?
Sorry, what?
Oh, 3. Okay.
Sorry, yeah, I'm jumping to number 3 just because of time.
Oh, I thought we were doing 1, so I was like, oh, okay.
Yeah, sorry. Yeah, so just equation.
So it would be minus x.
Good. Okay, got it.
And then it would be divided by 3, correct?
Yeah, you got it. Nice. So y is less than negative 1/3 of x plus 1. Okay, so let's graph that. We have a y-intercept of 1, slope of negative 1/3, and this is dashed. Ooh, I hope you guys remember to dash your graphs. Really, really hope you guys remember to do that. Okay. And now because it's less than, it would shade down towards the bottom of the y-axis. So I'm actually not going to shade it just yet. I'm just going to go ahead and draw arrows so I know what region to shade. The reason why I'm doing that is because I want to just leave the shading for my final answer. Okay, nice. Thank you, Timothy. Let's go to Riley. Riley, help me out with the second one. Put that into slope-intercept form for me.
So just subtract the x to the other side.
Good. So
and
negative x.
Divide everything
4.
by negative 2.
Good. And what do you have to be careful of when you divide by negative 2?
Flipping the sign.
Good. Nice, Riley. So flip the inequality when you divide by negative 2. Nice. All right, so we have negative 2 for the y-intercept, slope of positive 2, or sorry, slope of 1/2, so rise 1/2. And then we have a solid line here. And less than, so we would shade down towards the bottom of the y-axis. All right. So if you guys notice, right, where I would shade, let me go ahead and do a little bit of shading so you guys can see. this one I would shade here. And this one I would shade here. So you want to find the intersection of both of those regions. So let me erase those shading marks. And then your final intersection region, oh, that's going to take too long. All right, your final intersection region will be, oops. Okay, will be this region right here. All right, it looks kind of like a foot. Okay. So that's your final answer right there. Okay, any questions on that? All right, so that's basically it. Graph both and then find the intersection. Graph both, find the intersection. Okay, let me go on to number 4, a little bit tougher. All right, we have an absolute value of y is less than or equal to 1. All right, I'll just show you guys how to graph this one because this is a little bit tougher. What this means is that you got to split it because it's absolute value. Y can be less than or equal to 1, and y can be greater than or equal to -1. All right, so you got to do that split when you have those absolute values. So this will look like between +1 and -1 and shading towards the center. Okay, so that is what that graph would look like. Now, x is greater than 2. Let me do this in red. It'll be a vertical line at 2. Oh, sorry, that should be dashed because there's no equal. And greater than 2 means I'm going to shade to the right, right? I want bigger values of x. So I would shade to the right. All right, and then so my intersection will be in between those 2 green lines and to the right of the red line. All right, and that is your final answer. Okay, so those were kind of more unique graphs, okay? But the idea is the same, okay? Graph them, find the intersection. Okay, any questions on that one? Okay, all right, let's do one more, and if there's time, maybe we can go back for 1 or 2. Okay, number 5. Help me out with this one. Let me see. Paolo, how would you graph x is less than or equal to 2? What would that graph look like?
Would you just put it on the 2?
Good. And then solid or dashed?
Isn't that one dashed? Top one?
Look at that inequality. Is there an equal sign?
Oh yeah, it's
So
equal to.
The
So
line
it'd be solid then?
solid, good. And then would I shade to the left or right? If it's less than.
Would it be right?
So you want small values of x. So if you go to the right, you hit like 3, 4, 5. We want
Okay.
smaller than 2.
So it'd be left then?
Yeah, so you can go straight to the left. Good. All right, nice, Paul. Mateo, help me with the second one. How would I graph x is greater than 4?
A horizontal line at 4.
Ooh, careful. X is greater than 4, so it would be actually a
Vertical.
Vertical line, good. And this one I have to be careful, solid or dashed?
Dash.
Good. So we have a dashed line here. And Mateo, should I shade left or right?
Left.
I want
Oh, wait. Oh, right.
right, yeah. X is greater than 4. So we're going to shade to the right because that's where high numbers of X are, right? Like 5, 6, 7 would be to the right. Okay, so I want you guys to notice something. If I were to shade this region yellow, and then the solutions to the second one blue, where do they intersect? Anyone? Where do they intersect? Russell, what do you think?
They don't intersect.
Good, they don't intersect. So what does that mean?
Is it no solution?
Yes, good. No solution if there is no intersection.
Miss Leong,
Yeah, question.
how do you know when it's gonna go vertical and when it's gonna go horizontal?
Ooh, great question, Chris. When it is X is equal to a number, it's going to be vertical. If it's Y is equal to a number, then it's horizontal. Does that make sense?
Yeah, thank you.
Yeah, great question. Okay. All right, guys, let's see if number 1 is very, very similar to number 3. Okay. And number 2 is also similar, and it has just that, horizontal line at Y is greater than or equal to 1. So let me quickly check if I got all the work. So to show number 2 really quick, first I would make this into slope-intercept form by subtracting the 1. And I have a y-intercept of -1, slope of -1. So down 1, right 1. And I have a dashed line because there is no equal to in that inequality. Because it's less than, I'm going to shade down towards the bottom of the y-axis. Now, for the second one, this is a horizontal line because it's just y is equal to 1. And because it's greater than, I'm going to shade up towards the top of the y-axis. All right, then my final answer would be this intersection right here. Okay, guys, that is all the time we have. All right, starting with number 6, it says, find the coordinates of the vertices of the triangle formed by each system of inequalities. All right, so this is, this is lesson 3.2 on the back side, okay? 3.2. All right, so let's go ahead and graph the system of inequalities. So first thing I notice, I have the x greater than -3. So on the x-axis, there's -3. I'm going to have a vertical dashed line down. And since it's greater than, I am going to shade to the right. Okay, so big numbers for x. The next one, it is already in slope-intercept form, so that's very mighty kind of them. So I have a y-intercept of 3, slope of 1, -1 over 3. So down 1, right 3. Also a dashed line. And since it's less than, it's going to be shading towards the bottom of the y-axis. All right, and the last one, I have a y-intercept of -1, slope of +1. And I get this dashed line shading towards the top of the y-axis, since it is greater than. All right, so the overlap of all those will actually be the inside, which is a triangle. Okay. So now part A, the question is actually asking us to find the coordinates of the vertices. Okay. So if you graphed it very carefully, you can see the vertices right here at -3, +4. I have another one down here at -3, -4. And then this last one, I have 3, 2. All right, so those are the coordinates of the 3 vertices of that triangle. Let me take a pause. Any questions on that? Okay, then part B, it says find the area of the triangle. Ooh, does anybody remember the formula for the area of a triangle?
One half base times height.
Ooh, nice, Gio. Good. 1/2 base times height. All right, so pick your base really carefully. There's 3 sides of the triangle you can pick as the base. The easiest one would be this vertical line because you can just count to find the length. So if we count, that's 4, that's 4. This base has a length of 8. All right. And then the height will be the horizontal line going to that vertice. All right. So this height will be this length, which is 6. 1, 2, 3, 4, 5, 6. All right, so 1/2 base times height gets us 24 units squared, since we're talking about area. Okay, any questions on that? All right, then in our last few minutes then, we're gonna finish off with this word problem, which I'm gonna read fairly quickly. All right, so number 7 says the auditorium at McCaskey East High School in Lancaster, Pennsylvania has 800 seats. Suppose that the drama club has a goal of making $3,500 each night of their spring play to cover expenses and raise money for the club. Adult tickets are $7 and student senior tickets are $4. All right, so adult tickets we'll call A, student senior tickets we'll call S. Write a system of inequalities for the number of seats and the money raised by the drama club. All right, so since there are 800 seats, right, we know that the adult tickets plus the students' tickets total can't exceed the number of seats. So each night they can only have a total of 800 or less. You can sell less then, but you can't sell more than the number of seats you have. And their goal is to make $3,500 each night. So adult tickets are $7 each. Student tickets are $4 each. And we want to make sure it meets that goal of $3,500. And you can go over your goal, right? No one's going to be mad at you if you make $3,501, right? But you don't want to not meet your goal. All right, so there's your system. Let's go ahead and part B, graph the inequalities. So using the intercepts, let me use green for this one. I would have 800, 0, or 0, 800 for the intercepts of this first equation. So that would be my graph shading down. For this one, right, if the student ticket is 0, my adult ticket would be, oh, sorry, student is actually the X, A is the Y. Sorry, I kind of switched that around. So this would be 500 adult tickets And then if I do 3,500 divided by 4, I get 875 and then 0. So it'd be somewhere close to 900, but not quite. And this is greater than, so it's shading up. So this is the area that I want to be in. Okay. All right. And sorry if that's confusing. This should be the S. This is the A in my coordinate system. Since S is the horizontal, A is the vertical. Okay, and then part C says, could the club meet its goal by selling 200 adults and 475 student tickets? All right, so let's see. Adult tickets are $7 each, $4 each for the student tickets, and we want to see if it met the goal. Okay. If you were to calculate that, I think that ends up being 3,300. Let me check my key here. Yep, 3,300. I did not do that in my head. So unfortunately, that does not meet the goal. So no, it did not meet its goal. All right, and that is lesson 3.2. Any questions?